Okay, good evening. I am Professor David J. De Los Reyes. The date for tonight is May 23, 2023. The time is around 9:58 p.m. Okay, my topic for tonight will still be advanced mathematics. And for tonight, we will be deriving the so-called equivalent of tangent of x by using Maclaurin's series of expansion. Okay, let's proceed. I will check my camera. Oh, it's fine. So our topic for tonight will still be advanced mathematics. We are almost done with advanced mathematics. So my next topic, maybe on the long form video, will be algebra. Okay, let's proceed. For tonight, the topic is still advanced mathematics, lesson number 44. And the title of the topic is Maclaurin's series expansion of tangent of x up to 3 terms, meaning up to 3 decimal places on the right. Meaning we are solving tangent of x that comprises 3 terms. Okay, it could be plus, it could be plus, a minus, 3 terms, by using Maclaurin's series of expansion. This will now be an easy problem because we are done with the equivalent of sine of x by using Maclaurin's, and we are done with cosine by using again Maclaurin's. So if we try to bring out the equation using Maclaurin's, okay, it will now be, it's not an easy matter because we will be using the so-called long division or synthetic division. Okay, let's proceed. This part is actually the computation of the coefficients. I forgot to mark this one. Okay. And for this part here, it will be the long division and how to bring out tangent of x. Okay, let's proceed. Tangent of x is actually the ratio of sine x over cosine of x. That's trigonometry, right? Meaning tangent is sine over cosine. That is, in any right triangle, if this is x, okay, tangent will be the ratio of the opposite side over the adjacent side. Okay? And it will be the ratio sine x over cosine of x. Okay, I will erase this one. I just brought out that the so-called definition of tangent is the ratio sine of x over cosine of x. Okay, that's basic trigonometry. I will erase this one so it looks good. And from the previous lesson, sine of x is actually x minus x cubed over 3 factorial, this minus, plus x to the fifth over 5 factorial, plus some other values, which we will not include anymore. We are only after the solution that involves 3 parts on the right. That is, I will repeat it. Sine of x is actually x minus x cubed over 3 factorial plus x to the fifth over 5 factorial plus some other values. And for cosine, again, from the previous lesson, cosine of x is actually 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial. And as you notice it, under the sign, the exponent of x are actually in ascending order, starting from 1, the next will be 3, next will be 5. Actually, the next one will be to the power 7, then 9, but we'll stop doing that one. We just write up to the x to the fifth, right? X to the fifth. Okay? And for cosine, as you notice the powers of x, it's an even number. It starts from, actually there is an x to the 0 here. But luckily, the x to the 0 is actually, the power is actually 0. And x to the 0 is 1. So the first one is just simply 1 times x to the 0, or just simply 1. So if you try to notice the x terms for cosine, the powers of x are actually even numbers. 0 is considered even number, 2 is even number, 4 is even number. So we start with 0, 2, 4, maybe the next one will be 6, 8. Okay, but we stop up to x to the 4. Okay, I will erase this one. It is understood that there is an x to the 0 here, because x to the 0 is 1, and 1 times 1 is just 1. So from the previous lessons, okay, sine of x is this one. Hold on. Is this equation here. And cosine of x, again, from the previous lessons, it is actually this equation here. So for us to derive the equivalent of tangent of x by using Maclaurin's, since the derivation of this is Maclaurin, so if we use Maclaurin on both the sine and cosine, it is considered that the solution of tangent of x is used by using Maclaurin series of expansion. Okay? Since tangent of x is sine x over cosine of x, I just write it. We will be using the long division. Okay? So I will write first the numerator. The numerator is actually the first one. That is x minus x cubed over 3 factorial plus x to the 5th over 5 factorial. That's the numerator, right? And the divisor is actually the one at the bottom. It is this. 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial. For the meantime, we will just include 3 terms, okay? So if we now try to proceed with the long division, the first answer will be x, okay? It will be x. Why x? Okay, let's proceed. It is x. Why do we know it is x? The first answer is actually x, because if we try to multiply x times 1, that will be x, right? Then we try to perform the operation subtraction. This is subtraction. Okay? X minus x will be 0. So for your answer to be correct, if we try to multiply and then try to subtract, what will come out for the remainder should be 0 for your answer to be correct. So actually the first term of the answer is actually x. So if we try to multiply the first term by all these terms here, x times 1 is actually x, right? X times x squared over 2 factorial, x squared times x will be x cubed, right? Over 2 factorial, so this is actually over 2 factorial. This x cubed here emanates from the product x times x squared, right? Okay, the next one, x multiplied by x to the 4th over 4 factorial. X to the 4th times x to the first power will be x to the 5th power, right? The coefficient will be, this is all over 4 factorial. Because the coefficient of x for the meantime is 1, so 1 times 1 over 4 factorial will be 4 factorial. Then we try to perform the operation subtraction. So x minus x, it will be 0, okay? Minus x cubed over 3 factorial, okay? Minus, the operation is subtraction. This will now become plus, right? This will become plus because the operation is subtraction, okay? So the resulting coefficient of this will be the coefficient of this plus the coefficient of this. And what comes out is actually 1/3 x cubed. Meaning, if we try to take the difference of this, what will come out for the coefficient will be 1/3. Okay, and the variable thing is x cubed. Because this is under the column x cubed. How come this is 1/3? The solution, I did it separately. So for the coefficient calculation, okay, 1 over 3 factorial is minus 1 over 3 factorial. And if we try to perform the operation subtraction, the sign of this will be plus. So this is plus 1 over 2 factorial. Okay? We did it separately so we could visualize how come the coefficient came out as 1/3. So minus 1 over 3 factorial plus 1 over 2 factorial, this is minus 3 factorial is actually the product 3 times 2. So this is now 1/6, right? And that is 3 factorial. And 2 factorial is just simply 2 times 1. So this is now plus, the operation, this became now plus because the operation is subtraction, right? A minus minus, this will be plus. Plus 1/2. Then we try to combine this one here. So we are adding two fractions with different denominator. So to add it, okay, let's try to convert the second one with for the denominator to be 6. So we will multiply this by 3 over 3. Because 2 times 3 will be 6, and this is 6. So we could combine this one now. This will become minus 1. 1 times 3 will be plus 3. Under one common denominator, addition of fraction with different denominator, we convert first the second one to be with the denominator 6, so we could combine. So minus 1 plus 3 is actually 2 over 6. And 2 over 6 is actually 1/3. So this one here is this one. Okay? I did that separately. Okay? What will be the next one? X to the 5 over 5 factorial minus x to the 5 over 4 factorial. This is plus. So the coefficient of this, we will subtract the coefficient of this. The operation is subtraction. So what will come out? I will write the coefficient of x to the 5th will be 1 over 5 factorial. The operation is subtraction. This is minus 1 over 4 factorial. A minus and a plus is a minus. Right? And if we try to take the difference of this, if you don't expand the factorial, it's a complicated thing, but it should be something like this. You write first 5 factorial to be 5 times 4 times 3 times 2 times 1, and that is 120. And 4 factorial, we brought out the expansion of this separately. And 4 factorial is actually 4 times 3 times 2 times 1, and that is actually 24. So actually 1 over 5 factorial minus 1 over 4 factorial is the difference of the fraction 1 over 120 minus 1 over 24. But in here, we are adding two fractions with different denominator again. So we must have to convert the second one to be with the denominator 5. So we will multiply this by 5, and this is by 5. 24 by 5 will now be 120, so this is 120, so we could combine now, right? So this will become 1 over 120 minus 1 over 24 times 5 over 5. And 1, this is 1, minus 1 times 5 will be minus 5. All over the common denominator, this is 120, this is 120, all over the common denominator 120. So what will come out will be minus 4 over 120, and minus 4 over 120 is actually minus 1 over 30. So this coefficient minus 1 over 30 emanates from here. We did it separately for us to understand where the coefficient came from. Okay? So we now know the coefficients, right? So the next answer will be 1/3 x cubed. So 1/3 x cubed times 1 will be 1/3 x cubed. Okay? 1/3 x cubed times 1 is 1/3 x cubed. Okay? Then 1/3 x cubed times x squared over 2 factorial will be x squared x cubed, that will be x to the 5th. And if you try to combine 1/2, 1 over 2 factorial, which is actually 1/2, times 1/3, what will come out will be 1/6. So the coefficient of the second product, 1/3 x cubed times this, is actually minus 1/6 x to the 5th. Right? It is the product of this times the second one. This is where we get the coefficient minus 1/6. Okay, well, it is minus 1/2 plus 1/3. But it should be minus, right? Because this is minus and this is plus. The next one, 1/3 x cubed times x to the 4th over 4 factorial. x to the 4 times x to the third power, we will use laws of exponent. So it will be x to the 7, right? And what will be the coefficient? 1 over 4 factorial, okay, times 1/3. Okay? So what will come out will be 1 over 72. Is it 72? Because 4 factorial is 4 times 3 times 2. Right? 4 times 3 is 12, times 2 will be 24. 24 times 3 will be 72. So this is 1 over 72 x to the 7. So the product of 1/3 x cubed times x to the 4th over 4 factorial is actually 1 over 72 x to the 7. Okay? And again, you try to perform the operation subtraction. This is 1/3 x cubed minus 1/3 x cubed. It cancels out, right? So this is gone. Minus 1 over 30 minus plus 1/6. What will come out will be 2 over 15. That's how we got the coefficient. Right? Minus 1 over 30 minus open quantity minus 1/6. This will become plus 1/6. So meaning minus 1 over 30 plus 1/6. Okay? What will come out will be 2 over 15. Okay? What's next? The operation is subtraction, right? So we will bring down this one. This will become minus 1 over 72 times x to the 7. Right? And the next answer will be 2 over 15 x to the 5th. X to the 5th, 2 over 15 x to the 5th times 1 will be 2 over 15 x to the 5th. And x squared over 2 factorial times 2 over 15 x to the 5th, what will come out will be negative 1 over 15 x to the 7. Okay? Then again, try to perform the operation subtraction. So 2 over 15 x to the 5th minus 2 over 15 x to the 5th. They're the same, right? So they will cancel out. Since we are subtracting, we will this will now become plus, right? So for the resulting term that involves x to the 7, we'll just combine minus 112 plus 1 over 15. But I will not show you anymore because we will only be presenting 3 terms. So we will stop here. Okay? So by using long division, the long division came out that the answer will be this one. Okay, I will erase this one so it looks good. Right? So after long division, after bringing out 3 terms on the resulting answer, therefore now the equivalent of tangent of x will be x plus 1/3 x cubed plus 2 over 15 x to the 5th. The problem is only asking 3 terms equivalent on the right hand side. So we bring out 3 terms, 1, 2, 3, and we stop at that one because the resulting expression will be has some very so-called negligible effect on the value of tangent of x. So in general now, by using Maclaurin's series of expansion, tangent of x will be equal to x plus 1/3 x cubed plus 2 over 15 x to the 5th. That's our answer. Okay? And then bringing out this coefficient here, you should do like this. So you could visualize and you will minimize an error in bringing out the correct coefficient. So I presented the solution of the coefficient separately so you will understand. Okay, let's try to bring out an example. Let's try to check the validity of our answer. Example, find tangent of 45 degrees by using the derived equivalent of tangent of x. Okay, the solution will be something like this. 2 pi is 360, we divide it by 2, so pi will be 180. Dividing both sides of the equation by 4, pi over 4 will be 45 degrees. So the equivalent of 45 degrees in terms of radians is actually pi over 4 radians. Because in this equation here, x should be in radians. Okay? Don't try to substitute the value of x if the given value of x is in angle. You will be wrong. Convert that angle per to radians because that's the correct way on how to bring out the value of the right hand side. So if we now try to bring out tangent of 45 degrees by using this equation here, tangent of 45 degrees will be pi over 4, which is x, plus 1/3 x cubed, pi over 4 raised to the third power, plus 2 over 15, pi over 4 raised to the fifth power. So by using your calculator, this is now an easy matter. Why are we using this equation but we could solve or bring out the value of tangent of 45 degrees by using the calculator? We are studying mathematics and we are proving the validity or correctness of the derived equation. Okay? That's why I am presenting this example. And if we now try to calculate this one, pi over 4 will be 0.785 plus this 0.161. The third one will be 0.0398. And if we try to take the summation of this, what will come out will be almost 0.986. 0.986, that's almost equivalent to 1. So tangent of 45 degrees is actually 1. There's a little bit discrepancy because we stop at the third term. If we add one more, this will become 0.99 maybe. But just to show the validity or the correctness of the equation, we show this one. So now as the final answer, tangent of 45 degrees is actually 1. 45 degrees is actually a special angle because sine of 45 is actually equal to cosine and tangent is sine over cosine. Tangent of 45 degrees is actually 0.707 over 0.707. Because sine of 45 degrees is 0.707, that is 1 over square root of 2. And cosine is actually 0.707, that is actually 1 over square root of 2. And 0.707 divided by 0.707 is actually 1. And to check the validity, by pressing 45 degrees here, the unit should be degrees. Okay, then press tangent. Okay, the answer is 1. So the tangent of 45 degrees is 1, and by using the derived equivalent of tangent of x, by using maclaurin's, it is almost approximately equal to 1. That's it. So for those of you guys who are taking up advanced mathematics, this is for you. If you want to subscribe to my channel, long form video channel, okay, this is advanced mathematics. You can subscribe at youtube.com/@prof.davidj.delusris. And if you want to share it, please click share. Good evening from Los Angeles.